All right. Well, before we get started, I would like to go over a few items so you know how to participate in today's event. You have joined the presentation using your computer speaker system by default and are muted. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions panel of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Today's webinar is being recorded and you'll receive a follow-up email within 24 to 48 hours with a link to view the recording. A note for attendees is that the communication platform to be used to communicate important information throughout the World Affairs Conference is the WAC page on Instagram at World Affairs Con. All right, hello everyone. Welcome to today's webinar, Commercial Spaceflight, Humanity's Next Steps. My name is Parker Senst, I'm Brinksmell's plenary head for this webinar. I've had a passion for astronomy and astrophysics as far back as I can remember, and I've realized that the more we learn about space, the more there is to know. Is space actually our future, or is it our frontier? Dr. Lewis Friedman has not only been thinking about these questions for decades, but he's a published author who has a plan for humanity's future in space. And this isn't a plan that involves a plot line that you would see in a Christopher Nolan movie. Dr. Friedman has a plan that involves a plot line that gets us to Mars in our physical form and in interstellar space virtually. His alma maters include the University of Wisconsin, Cornell, and MIT. So buckle up for takeoff as we explore the possibility of interstellar travel and humanity's future in space. We will compare human versus virtual spaceflight with one of the world's greatest aerospace engineers, Dr. Lewis Friedman. For over 60 years, Dr. Friedman's work has impacted the world of aerospace engineering, and through his partnership with Dr. Carl Sagan and Dr. Bruce Murray, the Planetary Society was created and is still in operation today. We are extremely fortunate to have him speak to us today, and I'm very excited to warmly welcome Dr. Lewis Friedman to WAC. Hello, Dr. Friedman. Thanks so much for being here today. So as I said, I've been very passionate about astrophysics for a while, so I'd love to know what first sparked this interest in you, and what was it like pursuing your passion for aerospace engineering when it was a very uncharted field?
Well, thank you very much. I'm very glad to be here, and I really appreciate your interest and the interest of all those attending. I like most students, and like you probably, somewhere in junior high school and high school, I had an aptitude for math and science and taking various things. I knew I was headed out into that field. I liked it very much. I was pretty good at it, so I went in and started to go into engineering, and then as I mentioned, I was going into engineering, mathematics, and physics, back and forth between the sciences and the engineering. And I was really lucky. I mean, everybody will find out right now how old I really am, because I was really lucky. In my freshman year, Sputnik was launched, and I was at the University of Wisconsin when Sputnik was the top news in the world. Everybody was wondering about the satellite and what's the future. I never forget, the university reacted instantly. They formed a first space science course that was being taught at a major university. Dr. Werner Sumi, well-known meteorologist and atmospheric scientist, was a leading space scientist. He already had experiments that he was preparing for space missions. He came in the first day and he says, the first thing I need to tell you folks is every morning I get up a little grumpy and I get my pants on one leg at a time, and we space scientists are people. And basically then I was kind of hooked. I said that, they're doing such interesting things and they still remain to be people. And that's been a great opportunity, being with first with the Jet Propulsion Laboratory, working on NASA missions and during the heyday of planetary exploration in the 1970s, missions to Mars, the outer planets, and then the Voyager mission is still going, as a matter of fact. And then when Carl Sagan and Bruce Murray and I began talking about the political situation in the United States, where everybody loved these missions, but they were cutting the budget. In fact, there was a decision made that NASA would no longer do planetary missions. We said we got to do something about that, and what you do is you form a public interest organization and mobilize public opinion to support planetary science and space exploration, and that's what we've done.
Definitely. I remember being in science class and screaming with all of my classmates the theme song to Bill Nye the Science Guy, and now he's the CEO of the Planetary Society, and it has almost 500,000 followers on Instagram and a countless number of members globally. The Planetary Society is honestly incredible and has been a community that encourages people to learn more about space exploration. So I would like to know if the Planetary Society has become everything you and your co-founders have dreamt it to be.
Well, in a way, yeah, I guess I have to say yes, although I should never be satisfied. And I apologize for being a little satisfied, but uh, when Carl Sagan and Bruce Murray, who are extraordinary people, in fact, besides planetary science and the great missions we worked on, just working with those two people was fantastic. But when we were talking about it and we said, what would we do? We wanted to be more than just a Washington lobby organization, just lobbying for more missions. We wanted to do things. We wanted to help researchers. We wanted to even be a spawning new ideas. And I remember Carl saying to me one day, someday we may even get to conduct our own mission. I said, Carl, that's pretty ambitious. We're not NASA. But by golly, we did it in the light sail that flew in 2000. I mean that we started working on in 2000, flew much more recently. And we spawned a number of other ideas. I think we helped introduce rovers into the planetary science program. The Mars missions weren't getting supported at all. Nobody wanted to do rovers at all. Scientists used to think they were just stunts. They couldn't contribute, and we became great advocates of that. And we did it by working with people around the world, international cooperation. We worked with the Soviet Union, which most of your audience here, I'm sure, wasn't alive when there was a Soviet Union. It was, but the communists, working with the communists was a big controversial idea, but they had a great space program. They had a space station. They were doing missions to Venus and Mars. The United States was sort of dropping back. And so we began working with them, not just because international cooperation is good, which it is, especially in science, but because it stimulated the scientists in this country to stay active, even when there was these ups and downs in the budget cycle. And it turned out to be very, very valuable to bring in so many scientists to work on missions that did rovers to Mars and other innovative ideas for planetary exploration. So I think that long answer is really yes. Society has contributed both with mission ideas. It certainly contributed to the support of planetary science and planetary exploration, and it's an active, busy field right now. We're making discoveries.
Definitely. And in your answer, you mentioned solar sails, and you also mentioned that in the book Star Sailing and Human Spaceflight from Mars to the Stars, which you were the author of both. And so I understand some aspects of this technology, but could you break down for us essentially what solar sails are, how they work, and how you think they will impact the future of space travel?
Sure. Um, I'm going to add one sentence to my previous answer, though, that when we started, we basically said our goal was not just science, it was exploration. And what is exploration? I have a very simple definition. It's the sum of discovery and adventure. If you have discovery without adventure, that could be like maybe working in a laboratory. It's good science, it's great discovery, it could be the most important thing. It could be a new vaccine, it could be anything. It's very important, but it's less than, I think, the total of exploration. If it's just adventure without discovery, that can be tourists. You can go on exotic trips to all over the world. But you put those two together and you're really exploring. You're exploring your mind and your body in a way. And that's what the Planetary Society represents, is a push out on exploration. Solar sailing in some ways is the ultimate exploration. It's a technology that only works in space because it works on sunlight pressure, not the solar wind. If you've heard of the solar wind, it's not the wind. The wind is the photons and is the protons and the neutrons that are emitted from the sun. They're particles. They have mass. The order they push on the sail but it's 3 orders of magnitude less than the photon pressure, which is no mass but infinite, but much larger energy. The and the energy of the photons is what powers the sail, and the sail is then a giant reflector. You push light against it, bounce it off of it. That transfers the momentum to the sail. The larger the area, the more photons you collect. And so so you want a large sail and you want a low mass because the acceleration you get is proportional to the area divided by the mass. So you want small spacecraft in large area, and then your fuel source is the sun. So it's outside the sail. You don't have to carry your fuel along. And that's the big attraction. It can be all vehicle, and it can be a lightweight vehicle and a low cost vehicle. But it only works in space, of course. If you had on the ground, you can't even feel sunlight pressure. There's too many other forces here that doing. And it's very special because it's in the case where the ultimate goal is you can go great distances at enormous speeds without having to carry your propellant. If you have to carry your propellant, you're always limited. And the ultimate goal may be interstellar flight. Sailing would be the only way to do it, because if you have to carry your mass, even if you have to carry nuclear fuel, even if you have to carry matter and antimatter, you can't do interstellar flight in any practical way. Sailing is the only possible way. And of course, then it's not solar sailing, it would be a artificial laser sailing pushing it. Now, I have some thoughts on that subject, and we may get into that later. Even that's may be very hard, but the basic allure of solar sailing is that you can go faster and you don't have to carry your propellant.
Definitely. And what were your experiences like designing 3 different types of solar sails?
Well, I was very lucky working for Bruce Murray at JPL. We got very interested in a solar sail that could uniquely rendezvous with Halley's Comet. You may know that Halley's Comet comes into the solar system once every 76 years, and an object of extraordinary interest, a large, fairly large comet, certainly the largest, most repeatable periodic comet. And and the idea of a mission there was always in everybody's mind, and it was certainly in our mind. But to rendezvous with it, to match its speed, that was considered impossible, because it comes in the solar system backwards, retrograde motion, and at a high angle. So you could intercept it easily, but you couldn't actually match its speed, except with solar sailing. And that was the allure there. The sail would go in toward the sun, change its orbit, reverse its momentum in the solar system, and then fly and match speed with the sail. Now, the concept we had was even too big for its time. Had a very large sail, and so it was very hard. But the idea that it was theoretically possible to do a mission that couldn't be done any other way was what got me into solar sailing. That was the adventure part, if you will, and the idea that it could go to an object that hitherto wasn't visited. That's the science part. So it was exciting. So I started doing solar sailing at JPL. The mission, as I said, was too big for its time. It wouldn't even fit on the shuttle, which was supposedly the launch vehicle. The shuttle wasn't ready. And so that ended. We started working on other things, but I wrote that up in the book that you mentioned, and that led to my interest in solar sailing. And then nothing happened. A lot of people tried to do it. College groups got together. In fact, the group up there at the university in Canada got involved, and there was this effort to do privately funded projects as payloads from the shuttle to do solar sails to the moon. And but nothing really came of it. And a lot of people came to me and said, "We want to do this, we want to do that." And I said, "No, it has to be something real. We have to have a way to launch it. We have to be able to afford it." And then Russian colleagues were working on a completely different idea, inflatable structures for reentry vehicles. And they said, "We could inflate booms for the solar sail, and we'll build your spacecraft for you and launch it for free if you supply the sail." Well, that was the opportunity that we jumped on, and that's when the Planetary Society got into solar sailing. It was a great experience. We built a spacecraft. We think we built it successfully, but we'll never know because the launch failed 2005 on a Russian launch vehicle, and then the project started looking at what do we do next, and that led to light sail, and light sail now has ultimately succeeded. And I'll tell you, the two most important technologies that have come along, the most important technology for interstellar flight, I'll say it now, but it's true for the solar sail too, is not propulsion, it's small spacecraft. You make the mass small enough, you can do a lot of things, not just from the performance point of view, going fast and going far, but from the building it point of view. If you can build it on a table in a garage or a modest clean room, that's much easier than to hire giant hangars and rented facilities to try and build a large sail. So the small spacecraft revolution has really helped.
Definitely. Um, and also in your book, Human Spaceflight from Mars to the Stars, you mentioned that the human brain, but not the human body, will be incorporated into interstellar technologies. And this really caught my attention because, to be honest, this idea sounds like it is out of a sci-fi movie. So, how would this nanotechnology work to send our minds, but not our bodies, to space?
Well, thank you, because everybody else a lot of people accuse me of being negative because I said ultimately humans won't go beyond Mars. Uh, and I, I was kind of negative about the idea of humans will just keep moving outward in the solar system because what it ignores is the evolving of technology. Right now, if we do astronomical observations on a telescope at professional telescopes, we don't send astronomers up to the mountaintop and look through eyepieces. They sit in their universities and look on video screens. They do it remotely. Uh, Doctors, when they're operating, yeah, there's still some role for the hands getting in there, but much of it is done with remote operations. And our robotics field is taking huge strides in that regard. And the future of robotics, the future of artificial intelligence, future technology is going to apply to the space program just as much, of course. And of course, we've explored all the way out to Pluto, but the Kuiper Belt, whereas humans went to the moon 50 years ago, and they haven't gone any further. They haven't even gone that far again. And the technology now is still pretty much the same: bulky spacesuits and difficult life support systems. So I began to realize that when I went to a conference that some people organized on the future of interstellar flight. It was called the 100-Year Starship, and the idea was I listened to all these talks about how we're going to do interstellar flight, and I said, God, nothing's changed. They're talking the same as they were 40 years ago about matter, antimatter rockets, or warp drives, or generational spaceships with space arcs, and it's like reading science fiction books like when I was a kid. Um, they're not thinking about the modern technologies, and so that's what got me into it. And the idea that the sail, which I thought originally was going to be the way to go to the interstellar flight, but even that is limited. I realized that the future of spaceflight is going to take humans, I hope, to Mars. I mean, we haven't done that yet, and that would make us at least a multi-planet species and give us both the perspective and the physical well-being of being on two different worlds. Um, but then basically we'll be getting all of our information back from probes throughout the solar system and beyond. And that to me is where the future of space flight is going, exploring space flight.
And so I was just wondering, why do you believe Mars is humanity's best option for a habitable place to migrate compared to places like underwater or Earth's moon or the moons of the outer planets or somewhere else?
Well, um, Mars is the only accessible world, and accessible is a key idea, that has the stuff of life. It has water, it has atmosphere, and it has a vague connection to thinking that we could live there. It's not really habitable. If you were on the surface of Mars, you'd be dead in a millisecond. It's toxic surface. It's a vacuum. It's all poisonous atmosphere, and it's no protective ionosphere. So yeah, it's a toxic place. But we could, there are places, even in Canada, it's hard to live in the extreme environments. Uh, I've been actually up in Canada above the Arctic Circle. It's very hard to live there. You can only do it, and basically you create an artificial environment in your homes or in other facilities. So we have the stuff to do that on Mars, and it's the only world that we can access. Yes, Europa, in some sense, maybe under the surface, has something like that, but we can't reach Europa in any reasonable way. And by the time we do, we'll be way evolved. I mean, it's going to take hundreds of years to even do it on Mars, let alone going any further. So Mars is the only world. The moon is airless, of course, and it's even more hostile in the sense of being extreme cold or extreme uh, and nothing there. So Mars is the lure. Now, whether we will do that or not, I worry about that. I think if we only consider that we don't even have to make it to Mars, then what's the answer? We're hidebound on Earth. And that's both a physical limit and it's a psychological limit. I don't think we'll go to Mars to solve our overpopulation problem or our environmental problems. I think it'll help us understand them. But I do think that psychologically, if we are just limited to being on one world and that's the end of exploration, that's to me the downer for the human species idea. So I still have the goal that I think we want to continue to explore. I don't think it's a negative one in the sense that, well, if we get Mars, we can't get any further. Well, you'll get hundreds of years, maybe even thousands of years to explore Mars, and then we can worry about it after that. We'll not know what the technologies are. So that's why I say Mars is that just right distance to be very hard and questionable about whether we make it there. And it's a grand experiment. If we make it on Mars, we know the idea of moving out is possible. If we can't make it on Mars, that's a lesson to the whole universe. Making it out even to the world next door is impossible. So I think it's an important goal.
Definitely. And unfortunately, we are almost out of time, so I'm going to ask you one question. Um, so I'm sure that we've inspired a lot of people to start reading about interstellar travel and the future of humans in space. So I was wondering, on behalf of all the attendees here today, which of your books would you recommend as a starting point for your newly inspired?
Well, we've talked a lot about human spaceflight from Mars to the stars, and if you're students and if your audience is interested in these ideas of the future of exploration, I recommend that one. But if your audience is interested in what they're going to do, where they fit in, and why planetary science is a fun, exciting venture, read Planetary Adventures from Moscow to Mars, and you'll see that it took me into doing things that I never imagined a major in science or a major in engineering would take me into, going to the Soviet Union and involved in some of the great political aspects of what was going on in the world, on the world stage, and international cooperation. That was a real benefit.
Well, thank you very much, Dr. Friedman, for speaking with us today and making the World Affairs Conference absolutely remarkable. On behalf of WAC, we will be sending you a token of our appreciation to further thank you for sharing your expert perspective on the possibility of interstellar travel. We are so grateful that you made the time, especially very early in the morning for you, to share your passion for space with us. You've inspired so many students today to explore space and run after their curiosity. So thank you, Dr. Friedman. I hope you have a great rest of your morning.
Well, thank you very much. I appreciate it.
No problem. And once you leave today's webinar, you'll receive a survey on the presentation. We would appreciate it if you would complete that and provide your feedback. You will also receive a follow-up email within 24 to 48 hours with a link to view a recording of today's webinar. Please navigate to your links hub on worldaffairs.ucc.owen.ca to attend the following events. Immediately following this plenary at 11:15 a.m. EST, the programs team is hosting a startup exhibition during lunch on Zoom. This is a drop-in style chat in breakout rooms where you will have the opportunity to ask professional and student startups questions about their entrepreneurial journey. Please refer to your personal schedule on the WAC website for the list of startups and their corresponding Zoom links. At 11:50 a.m. EST, the WAC 2021 keynote address, delivered by renowned poet and professor Dr. George Elliott Clark, will take place on GoToWebinar. Please refer to your personal schedule on the WAC website for the webinar link. On behalf of the World Affairs Conference and our presenters, thank you for joining us and have a great rest of your day. Great. Thank you.